Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see the lead code problem, that is coin change. We have already seen this problem. We have already done this problem via brute force and then dynamic programming memoization technique, top down approach. Now today we will see the bottom up approach of dynamic programming, that is tabulation method. So the aim of the uh, problem is the same, that we have to find the fewest number of coins that will make up that amount. So if I've already explained the problem in more deep and how to come up with a solution to dynamic programming, so please watch that video. I will paste the link in the description link of this video, and then you can come back as a continuation for this video for this problem. Now let's see the tabulation method. So I've taken one example here where I have the denominations of coins as 1, 2, 3, and now we have I have the coins denomination as 1, 2, 3, and I have to find the minimum number of coins for amount equal to 6. So for the tabulation method, we know it's a bottom up approach. Like we know already the optimal solution for smaller sub problems. For smaller problems, we have to find for the larger sub problems with the help of smaller sub problems. So as in the recursion or in the memoization top down approach, our base case was f0 equal to 0. Now again here it will be the same, like f0 means the number of minimum number of coins to make sum 0, and we know it is 0 because we don't need any coins. So for f of 1, like the minimum number of coins to make the to make up to the amount 1 is the sum of the minimum number of coins that can be done by subtracting all the denominations, right? But if you can see 2 and 3 coins are greater than the sum, so we'll skip that. So if I subtract 1 minus 1, it will be 0. So f of 0, so f of 1 is nothing but f of 0. So it will be, we have to take minimum of all these 3, right? As we talked about, the f of s is equal to f of s minus c plus 1, and f of s minus c is minimum of f s minus c1 comma f s minus c2 dash f s minus cn, where n equal to number of coins. So if we want to calculate the sum, if we calculate the minimum number of coins for the amount s, we have to calculate the minimum number of coins for a sum that is calculated by subtracting each of the denominations. So where we are subtracting the sum from for each denominations, and the resultant will be will give us the minimum number of coins for that sub problem. So for f1 we need f0 because 1 minus 1 is f0, and we will add 1 to it. So f0 is 0, so 0 plus 1 is 1. For f2 means for 2 it will be 2 minus 1, that is 1, that is f of 1. 2 minus 2, that is f of 0, and 2 minus 3 is not applicable because denomination is bigger than the amount. So minimum of f1 and f0, so f1 is 1, f0 is 0, so minimum of f1 f0 is 0, and 0 plus 1 is equal to 1. So it will be 0 plus 1 equal to 1. Now again for 3 minus 1 is f of 2, and 3 minus 2 is f of 1, and 3 minus 3 is f of 0. So minimum of f2 f1 f1 is 1, is f0, so it will, the value of f0 is 0 plus 1, that is 1. For f4 it will be f3, f2 and f1. So the minimum value is 1, so 1 plus 1 is 2 for f1. For f5 it will be f4, 5 minus 2 f3, 5 minus 3 f2. So the minimum value of f2 is 1, so 1 plus 1 equal to 2. So for f6, 6 minus 1, that is f5, 6 minus 2, that is f4, and 6 minus 3 is f3. So the minimum value is f3, that is 1 plus 1 equal to 2. So the minimum number of coins will be stored in f of 6 for 6. So the minimum number of coins is 3 plus 3, that is 2. That is the answer, we got it. So let's see the code for this program. So here we have initialized the max as amount plus 1, because for the DP will take amount plus 1, the size will be amount plus 1 because it's a 1 based index. We'll fill the DP with max value because the value cannot be greater than the maximum amount. Now we know that DP of 0 is 0, and for each amount from starting from 1 less than equal to the amount, we'll iterate over all the coins, and we will see that if coins j is less than equal to I, means the denomination of the coin should be less than equal to the amount, and if it's less than the amount, then we'll update the DP of I equal to the minimum I comma DPI minus coins j plus 1. So for every coin denomination we are doing the DPI minus coins j, and we are comparing with the current DPI. If the minimum of both, we are updating DPI with the minimum of the both. So if suppose if at f2 we've subtracted f2 minus 1, 2 minus 1 for 2, because we want to check for if we want to check the minimum for the 2, new number of coins that we want for the 2, we have to subtract each coin's denomination to get a sum, and for that sum we have to find the minimum number of coins needed, right? So if I want the sum for 2, I need to find the minimum number of coins for 2 minus 1, that is f1 amount, and 2 minus 2, that is f of 0 amount. So for f1 or f0, the minimum number of coins to reach either of the two is 0 for f0, and then we plus add 1 to reach it to 1. So f2 will also become 1. The minimum number of coins that will amount to 2 is 1. And after this for loop is completed, we'll do DP of amount. If it is greater than amount, then we'll return minus 1. It means that there is the amount is greater than the denomination, and there is no denomination of the coins that make up to amount, some amount. So for example, if I say if the coin available is 2 and the amount is 3, so no way we can take any number of coins of 2 to make up to the amount at 3. right? Because the minimum will be 2, and if we add 2 plus 2 it will be 4, so we can never make 3. So in that case we have to return -1, otherwise we'll return the dp of amount, because we saw that the final f6 or dp6 will contain the minimum number of coins for the sum 6 or the sum I. So let's talk about the time complexity of this. So we are running two for loops. One is over the amount and one is over the coins. So for each amount, the it will be iterating over coins. So it's simply big O of amount cross coins. So hope you like this video. Let's try to run this program. So yeah, the test cases are passing. So thanks for watching this video. I hope you like this video. If you like this video, please share and subscribe for more such videos. Thank you.